Let's talk about, everybody have your calculators out. You need them, you need them, you need them. We're going to, this is 3334. 3334. Yeah, 3334. We're going to talk about condensing and expanding, which is 333, and then solving is 34. So, first of all, we talked in our calculators, right? There's a log button. What is the little number next to log that's already programmed in your calculator? 10, okay? Some of you have a change of base formula built into your calculator. Some of you do not. I am not going to go through and figure out who has what. If you want to Google it, you're welcome to. That's fine. But if you have something like this is not log base 10. It's log base what? 4. You can do what's called a change of base, all right? All of these answers, we're going to get really weird decimals, and that's okay. That's why logs and exponentials will give you that. But in order to do this in your calculator, this is how Mrs. Meadow says it. It's log of big over log little. Now, I'm not talking about in numerical value. When I look at log 4 of 25, what is the bigger number? 25. It's visually bigger, right? So in your calculators, you guys would hit log 25 divided by log 4. It's log of the visually bigger number over log of the visually smaller number. So hit log. Everybody do it with me. Everybody practice this. This is important. What'd you get? 2.32. Let's go to 3 decimal places. 321. Okay, fine. 90% of the time, it'll tell you to round to 3. But that's the change of base. You're going to need that later on when we're solving. You're going to get something where you have to give me the answer to this. That's how you would do it. So same thing here. It's log of the visually bigger number. So you would hit log 12 divided by log 2. What do you guys get? Just practice in your calculator. 3.584. Okay, fine. Sounds good. Now, let me do an example over here just in case. Say you have log 3 of 5/4. What is the visually bigger number?
3.
No, visually bigger.
5.
I know numerically 3 is bigger. But which number, when you look at it, is visually bigger? 5/4. So you would do in your calculator log, put 5/4 in a parenthesis. Some of you have to hit 5 divided by 4. Some of you, it does a little like fraction for you, whatever.
When you mean like visually bigger, like, are you talking about like the size?
Not numerically, like 3 is bigger than 5/4. I mean, when I look at it, which number is like bigger?
Like bigger, like in size.
Visually, which is bigger? Yes. So what do you guys get when you get this? What is log of 5/4 divided by log 3? What is it? 0.2 what? 0.203? Okay. Guys, can you take the log of a negative number? No. If you're not sure, this is going to be the great thing about having a calculator. You plug it in and your calculator will tell you error, something, or domain error, undefined, something. It'll tell you no way. All right, look at the next one. This is the exact same thing. But you have to remember, guys, exponentials and logs are opposites or inverses of each other. What is the inverse of ln? E. It's on the same button. They're both still exponentials and logarithmics. They're just really specific ones. So if you're going to change this base using the natural logarithm, instead of hitting the log button, use the ln button. Same thing. We're going to say ln 25 over ln of 4. Tell me what you get. 2.32. Is that what we got up here?
Yeah.
You got the same thing, right? Because they're the same thing, guys. This would be ln 12 over ln 2. What do you get? $3.584. Same thing. So when we get to solving in just a second, the biggest thing to remember is that, look at your buttons. Log and exponential are on the same button. Those are inverses. ln and e are on the same button. Those are inverses. Okay, here we're going to talk about expanding and condensing, and it really and truly is as easy as I'm going to make it, I promise you. When you condense, what are you doing? You're making stuff smaller. When you expand, you're doing what? You're making things bigger. So we're going to talk about three properties that you guys are already very well aware of. If I talk about the product property, do you see here, and they show it with both log and natural log because it's the same thing. Do you see here, did we start off here, is this smushed together or is it pulled apart? That's smushed together. Do you see over here, this is the pulled apart version of it? So this is the condensed version, and this is the expanded version. So you're going to be given a problem where it's already condensed and you have to pull it apart, expand it, or it's pulled apart and you got to smush it together. But notice the relationship here. When it's smushed together, you have log base whatever, and then what's being done right here with u and v? They're being multiplied. Okay, guys, remember multiplication is just repeated addition. So multiplication and addition go together. So when you are condensed, you're stuck together, and you're going to pull it apart, notice what happened. Everything that's being multiplied together, it gets its own log, and you just put a plus sign in between it. If it was already pulled apart and there was a plus sign, that means you do what? Oh, if it's already added, when you smush it together, what are you going to do those two things? Multiply. All right, same thing here. Look at the second one. What's going on here with u and v? Division. Well, what goes with division? Subtraction. When you see something that is divided, when you pull it apart, each thing gets its own log, and you put a minus sign with it. If there's a minus sign in it already pulled apart, when you smush it back together, that just means division. And the last thing here, what is this right here? This is a what? It's an exponent, and then what does it become over here? A coefficient. Exponents become coefficients and vice versa. If you are going to pull this apart, you take this exponent and you put it out in front. If you're going to smush it back together, you take the coefficient and it becomes an exponent. So the easiest way to do these is to first look at the problem and say, all right, is this already expanded and I have to smush it together, or is it already smushed together and I have to pull it apart? And then walk yourself through the things that you have to do. All right, we're going to skip to the next example. I went off because we don't need to do it right now. All right, so your problems will say condense or expand. God bless you. It's not going to tell you exactly what to do. So if you look at letter A, is letter A already smushed together, or is it pulled apart? And every single term has its own log, and it's really long and pulled apart. It's smushed together already. So let's think about this for a second. Just look. How many different terms do you see? I see 3. I see a 5. I see an x to the third, and I see a y. Do you guys see that? What's going on between the 5, the x to the third, and the y? This is all multiplication. So what is it going to become when we pull it apart? We're going to become addition. Good. Now, you don't have to do this part. It's just good to think. What is this 3 going to become? It's going to become a coefficient because it's already a what? It's an exponent. So when you pull it apart, it's going to become a coefficient. So when you guys pull these apart, every single thing gets its own log. So I'm going to rewrite log 4 how many times? 3. Now I'm going to do this in 2 steps. Some of you are going to want to do it in 1, and that's fine. But I'm going to rewrite this as log little 4, and then I have a 5, plus log x cubed plus log 4 y. Now some of you are like, can I just go ahead and put the 3 out in front? Yes, you can. But I like to do it in steps just to make sure I see, okay, everything got its own. Okay, we're good. Notice, guys, my 4 is tiny. Don't make the 4 and the 5 or the 4 and the x or the 4 and the y the same size, because then it changes the value. Now, what's one more thing I have to do to fully expand this? This 3 needs to come right there. So I have log little 4 of 5 plus 3 log little 4x plus log little 4 of y. And there you're fully expanded. You pulled the whole thing apart.
Does it matter what order you do it in?
This doesn't matter the order because it's all multiplication. But if there was division, then yeah. I would just go just how you see it, just how you write it, like left to right. All right, let's look at B. All right, there's a lot of things going on with B. I see two really major things. What's one of the things that you see? Okay, I see division. Good. Division's going to become what? Subtraction. And Marcella, what'd you say? There's a radical. All right, we didn't talk about radicals, did we? No. But we can rewrite that radical. I can rewrite this radical. I can rewrite this as ln, and I can write this as 3x minus 5. What is the square root? How can I write that as a power?
1/2.
1/2, 1/2. If I had the cube root, what power could I write that as? 1/3. If I had the fifth root, what power could I write that as? If I had the fifth root, what could I write it as? 1/5. Okay, good. All right, so now I'm looking and I say, okay, I see a power. A power is going to become a what? It's going to become a coefficient. Good. You got it. I knew you had it. And then again, this is going to become subtraction, right? Okay, good. So I'm going to rewrite ln. And I'm going to write this as 3x minus 5 to the 1/2. Could you go ahead and write the 1/2 out in front? Yes, but I don't want to yet. And then what does my division become? Minus. So I have the ln of 7. Every single thing gets its own log or natural log. Now the next step I have to do is take this 1/2 and put it where? Out in front. So you have 1/2 natural log of 3x minus 5 minus the natural log of 7. When you pull everything apart, you want it nice and flat. No exponents left over, nothing being multiplied, nothing being divided. All right, we good? All right, so there we started with condensing. We started condensed and we pulled it apart. What does this look like it is? It's already pulled apart. What do we have to do? We got to smush it back together. So before you guys just try it, okay, let me just do it all at one time. Think about this. Look at letter A. What is 1/2 going to become? An exponent. What is 3 going to become? An exponent. And what is the plus going to become? Good. You just walked yourself through what you need to do to smush this back together. So you can do just that. I'm going to write A. How many times am I going to write log base 10? Once. I'm going to write it out here in front, and then I'm not going to write it again. So I'm going to write x to the 1/2, right? My 1/2 became my exponent. What did that plus mean again? Multiplication.
Do we need to write the base 10?
No. You don't have to write base 10 if it's 10 because it's understood. I'm just doing it just because it's in the problem. So then this becomes x plus 1 to the 3rd power. Yeah? You guys agree? Now there's one more thing that I would want you to do to simplify. What do you think that is? What should I rewrite x to the 1/2 as? The square root of x, yep. You do not have to multiply this out anymore, guys. You're just smushing it back together. That's fine. You can leave it just like that. You do not have to cube x plus 1 and then multiply the square root of x in it. But the easiest thing to do is just kind of survey the situation for a second. Before you try and start pulling it apart or smush it back together, look and see what you have. Draw yourself little arrows. Draw yourself little notes. It's much easier if you do that. Let's look at B. What do you guys, what do you see in B? Okay, the 2 is going to become a? Okay, good. Agreed. What is that minus sign going to become? Division. Very good. So you still have a logarithmic function. It just happens to be a natural log. So I'm going to rewrite this as B. I'm going to write ln one time. And then I have x plus 2. You guys told me this was squared, right? Over what?
X.
That's it. Is there anything else you could smush together? No.
Does it matter if the ln's also?
As long as it's out in front. You only want it one time. I would just stick it out in front. Can you guys cross off x's there? No. Okay. So don't start making up your own math. You laugh. Sometimes I look at stuff and I'm like, there's no way I said that. All right, look at this one's a tad bit more involved, but nothing we can't handle. What do you notice about that 1/3? It's outside. So everything inside is to the what power? To the 1/3. How would I rewrite that? At the end, how am I going to write something to the 1/3 power?
The cube.
Perfect. Cube root. Good. All right. What else do we see?
There's division and multiplication.
Well, hold on one second. I see a multiplication here, right? Does this become a division?
No.
Why not? Because it's in a parenthesis. It's stuck together. So we just leave that alone. That's fine. That's good, though. All right, so I'm going to do this in a couple steps here, just to make sure we can see this okay. So here's C. I'm going to rewrite this as log 2 of x plus log 2 of x minus 4, all raised to what? The 1/3 power. So I know at the end, I'm going to do what to that whole thing? I'm going to take the what? The cube root, okay? So if I rewrite this, how many log 2's am I going to have? 1. I have 1 log 2. I'm going to write it out here out in front. And then I have x, what? Times x minus 4, right? And this whole thing is raised to what? The 1/3 power. So the last thing I would do to simplify this is I would keep my big log 2, log base 2. What did I tell you about the 2? Make it tiny. And then I'm going to have this whole expression, x times x minus 4, but it's going to be underneath what? The cube root. Perfect. If it's to the 1/5 power, then it's the 5th root. If it's the 1/8 power, it's the 8th root. And there you go. If you guys, I'm telling you, if the problem is really, really long, if you just take your time and go, okay, this coefficient's going to become an exponent. This addition's going to become multiplication, vice versa. You'll be good to go. Yes, ma'am.
So even though the brackets that say like 1, the power is like 1/3 around the log.
Yes, it's telling you that whole thing, that the expression, not the log itself, is going to be, yeah. All right, we good? Mm-hmm.
Would it be okay if I were to write them both in parentheses?
Sure.
Okay.
Yeah. If you want to write them both like that in parentheses, that's fine. All right, that's condensing and expanding, guys. It's not that terrible of a concept. Now we're going to get to solving, which I really and truly, there's one pre-calc step to solving, then the rest of it is just solving normal equations like you guys have done your whole life. All right, up here, it just gives you some examples. When we have 1-to-1, remember, what does 1-to-1 mean? When you can use the 1-to-1 property, you can you can get the base to be the same, God bless you. Cross off log, something like that they're the same on either side. When you get here, it says you have to use what? Inverse. This is solving like anything. If you had 2 times x, you would divide by 2. If you had x plus 7, you would subtract 7. So what you guys need to remember is that ln and e are inverses of each other. If you start off with an e in your problem, you know at some point you're going to take the natural log. If you start off with a natural log, you know at some point you're going to have to raise something to e to the x. And then your other exponentials would be log and 10 to the x. Those are inverses of each other. These are inverses of each other. This is how we're going to undo to solve. Now, all of these, you guys can check your answers. We may not get through all of them today. That's fine. I'll finish up tomorrow, and then I'll let you guys start on the review because it's really long. I made it really long so you can just practice a bunch. I'll post it so you guys can see it. So what I'm going to tell you to do every single time is identify first what kind of a problem do you have. Is this an exponential? Letter A. Am I starting off as an exponential or am I starting off as a logarithmic? It's an exponential. All right, this is one of those special exponentials. It's an E, right? So think it to yourself. What is the opposite of E? ln. So at some point, you're going to have to use that, yeah? So this is how we go about solving. We say, okay, I have e to the x equals 72. You want to isolate your function. Is e to the x by itself? Yeah, there's nothing else being added, subtracted, multiplied, nothing. So your next step, this is your pre-calc step. How do you get e to go away? ln. What you do to one side of the equation, you do where?
To the other.
So look, I'm going to take the ln of e to the x, and I'm going to take the ln of 72. What happens with E and ln on the left-hand side? They cancel out, so I get E equals, now in your calculator, you hit natural log or ln, 72. What do you get? Give me 3 decimal places. 4.277. 4.277. Now, what can I do with that answer? I can plug it back in. In your calculator, if you wanted to check, just hit second ln, which is the E button, and then hit 4.277. And I got 72.024. Is that pretty close to 72? Yeah. Yes. So no, you're right. That's it. You have to kind of survey the situation, see what's going on, and then figure out how you're going to solve it. Let's look at B. Okay, same thing. I have 3 times 2 to the x equals 42. So think about it. We're going to go through the same process. I want to get my function by itself. What kind of a function am I starting off with? Is that a log function or is that an exponential? It's an exponential. There's a variable in the exponent. So that means at some point, what's the opposite of exponential? Nuh-uh. Opposite of E is ln. What's the opposite of an exponential function? Log. At some point, you're going to use the log. But I have to get that 2 to the x by itself. So what do I do first? Divide both sides by 3, okay? Normal solving, how you would solve anything. Divide by 3, divide by 3. So I have 2 to the x equals, what's 42 divided by 3? 14? Okay. All right, is my exponential function all by itself now? Yes, but we already know how to do this, guys. What is the opposite of an exponential function? A log. All right, we talked about this when we were finding our x-intercepts. Can I take the log little base 2 over here? Why am I using 2? Where'd I get 2 from? Because the base is 2. What you do to one side, you do where? So I have log little 2 of 14. What happens to log little 2 big 2? It cancels out. So I have x equals. Do you guys know how to do log 2 of 14 in your calculator? Yeah, you hit log 14 divided by log 2. So when I hit log 14 divided by log 2, what do you guys get? X equals 3.807. Now, if I tell you 3, I want 3. If you put 806 or 80, it's not that big of a deal. And what can I do with this answer to make sure that I'm right? I can plug it right back in there. When I do, should I get something real close to 42? Yeah. Is it going to be exact? No. But I'm telling you guys, these are not super difficult problems. The biggest thing is to first look and say, okay, I'm starting with this, so at some point I'm going to have to do the inverse, and then get the function by itself. All right, let's scoot over to 3. Highlight your function. Think about this for a second. I have to get that by itself, but what is the opposite of E? ln. Look at your calculator. If you guys are confused, if you're like, I don't know what to do, look at your calculator. E and ln are on the same button. Before I can do anything, though, what do I have to? I have to do what first? I have to add 3 to both sides, right? Our normal, how we would solve any other equation. So I have 4 e to the 2x equals 2 plus 3 is what? Good. Now what? Divide by 4. Perfect. So I have e to the 2x equals 5/4. All right. There's nothing else I can do to get e by itself. It's totally solo. What is the opposite, ladies and gents, of e? ln. So if I take the ln of this side, I have to do what? The ln of this side. Perfect. What happens with e and ln? They cancel out. So I have 2x equals, guys, in your calculator, hit ln, and then put 5 divided by 4. This is where rounding is very important. Don't round to 1 decimal place. Round to at least 3, because you're probably going to have to round a couple times in these problems. And the more you round inside the problem, the further and further away you get from the answer. So to 3 decimal places, what do you get for the natural log of 5/4? Okay, 0.223, correct? And then what's my last step? Divide by 2. So x equals, you can just hit divided by 2 in your calculator. 0.11, all right, so 0.11, say 2. And what can I do with that? I can plug it right back in there, and you guys can use your calculator. Now, the only step, guys, the only step that used pre-calc is right there. That's it. Just knowing that E and ln were inverses of each other.
What was the final answer for B?
3.807, yeah. All right, you guys okay?
Yes.
All right, let's scoot. We're just going to do a bunch of examples. All right, I'm going to rewrite this with an X because I don't like T's. But first thing I'm going to do, look at your function. What are you starting off with here? Is this a logarithmic? Do you see the word log or ln? Or is there a variable and an exponent? This is exponential. So you know at some point you're going to have to do what? Log, right? You're starting off with exponential, so at some point you're going to have to use log. I don't have an E. If you have an E, then it's ln. But if you don't have that, then you know it's log. So I'm going to rewrite this. Well, in a second. What am I going to do first? There's two things I need to do before I can do my pre-calc part. I'm going to add 4. Good. So I have 2 to the 3. I'm going to say x. So 2x minus 5 equals 15, right? And now what? Divide by 2. Now, I'm going to give you guys some options here. 3 to the 2x minus 5 equals, you can leave this as 15 over 2 if you want. You can go ahead and divide it and get a decimal. That's fine. Whatever you want to do. I'm just going to leave it. Just easier for me. Now, is there anything else being added, subtracted, multiplied, or divided to my 3 to the 2x minus 5? No. So what did you guys just tell me that I was going to have to do to undo this? A log. What little tiny number am I going to use? Why is it 3? Because the base is 3. So I have log little 3. What you do to one side, guys, you do where? So log little 3. So on the left-hand side, these cancel, and then my exponent just comes down. 2x minus 5 equals. Remember, in your calculator, to do this, you need to keep 15 over 2 in a parenthesis. If you changed it to 7.5, whatever. But in your calculator, it needs to say log of 15 over 2 divided by log 3. So log, excuse me, 15 divided by 2, close your parenthesis, divided by log 3. What do you guys get? 1.834. Perfect. Now, am I done? No, but everybody in here knows how to solve this equation. Now, what do I do to both sides? Add 5. Perfect. So 2x equals 6.834. And then what? Divide by 2. Perfect. So x equals what? 3.417? 3.417. Now, what can I do with that beautiful decimal to check? You can take this right here and plug it right there. And just see, you should get something really close to 11. Everybody with? All right, let's keep scooting. I don't want to skip any. I know I have them all over the place. All right, so now we're starting off a little different. I have a natural log of 3x equals 2. Notice where the 3 is. Is the 3 being multiplied or divided to the log itself? No, this is part of, it's stuck together. Do you see how the 3 is in between the natural log and the x? You can't divide both sides by 3 on this. Is anything being added, subtracted, multiplied, or divided to my natural log? No. So I think about this. I'm like, okay, the natural log is by itself. What is the opposite? What's the inverse of ln? Look at your calculator. E. All right, so if I write a big E, what goes into the exponent? ln, 3 to the x. Everything goes into the exponent. Just like when we solved for our intercepts, right? If I write a big E and everything goes into the exponent on the left-hand side, what do I do on the right-hand side? I write a big E and then 2 goes into my exponent. Now it's one of those properties. The reason that we learn those properties is because now you guys see, oh wait, E to the ln does what?
Cancel.
It cancels. So I just have 3x equals, what's e squared? Einstein's. Say it one more time. 7.389. Okay, I'll go with that. And then what do I do to get x? Divide by 3. Perfect. So x equals 2.463. Perfect. And what can I do with that? You can plug it back in. Guys, it's real important to plug back in when you start off with ln or if you start off with log. And why is that? You can't take what? Can you take the log of a negative number? No, so we've got to make sure. You can have a negative exponent, that's fine. But you've got to make sure that when you plug your answer back in, it does not make your log or your natural log negative. Because if it does, then it's an extraneous solution. It doesn't work. All right, now we're starting to get some real hard ones. What do you notice here about b? Anybody notice anything? The logs are the same. So what can I do if the logs are the same? I can cross them off. If you guys don't see that and you're like, I don't know what to do. Well, what's the opposite of log?
10 x.
Exponential. So if my little number is 3, what would my big base become? 3. So do you guys agree you'd put a 3 on this side and a 3 on this side? They would just cancel? That's why that happens. If you have one log on the left-hand side, that's the same as one log on the other side. You cross them out. So you guys, for B, you have 5x minus 1 equals x plus 7. Now, if you don't know that property, then you guys are sitting there beating on your calculator trying to figure stuff out, right? But if you know that property, you're like, oh, this is a very simple equation. So if I solve this, I'm going to move x to the left, so minus x. I'm going to add 1 to both sides. So 4x equals 8. Okay, divide both sides by 4, and x is what? Now, this is where it's really important to check. When you have an exponential and you just plug it back in, you just want to check to make sure you did your math right. Here, you have to check because you cannot take the log of what? A negative. You don't have to physically plug this into your calculator. You just need to say, okay, if I put a 2 here, what's 5 times 2? 10, and 10 minus 1, is that a positive? Okay, we're good. If I put 2 here, what's 2 plus 7? 9, that's positive, right? So think about it, guys. 10 minus 1 would be 9, right? 2 plus 7 is 9. So you'd have log 3 of 9 equals log 3 of 9. Is that true? Yeah, you're good to go. You just want to plug it in and make sure it does not become negative. Super important. All right, let's look at 7. Look at, just highlight it. Check out, survey the situation. See what's going on. I have a natural log of x. So in my mind, I'm like, okay, I need to get that by itself. But what is the opposite of ln? E. So at some point, I'm going to put a big E. And then what's going to go up in the exponent? Anything that's there. Like anything that's there. You're right, ln of x. But I got to get that ln by itself. So what are the 2 things I need to do?
Subtract 5.
Got to subtract 5. Great. So I have 2. The natural log of x equals negative 1, right? Then what? Divide by 2. So I have the natural log of x equals negative 1/2. Now, can I just say, oh, this is no solution?
No.
No. The value of x cannot be negative. It's not that your answer can't be negative. The value of x. So now you guys just told me, what is the opposite of ln? E. So I put big fat E over here. And then I do what? Big E over there. So E and ln do what? Cancel. So what is E to the negative 1/2? What was it? I'm sorry? 607. Okay. Now think about it. You cannot take the log or the natural log of a negative number. If I put this right here, is 0.607 a negative number? No, then you're good. If it was negative 0.607, it would be no solution. You cannot say right here it's no solution just because the natural log equals a negative number. You can't take the natural log or log of a negative number. Big difference there. Any more on this page? All right, we're going to get through all of this. I'm so excited. Actually, I'm going to add 1. Do you guys share my enthusiasm? Nope. Got it. Thanks. Okay. Happy Monday after homecoming, folks. All right, let's look. Identify the issue here. Notice that 3. It is stuck in between log 5 and the x. You cannot divide by it. That's why I say it's a good idea to highlight, circle, isolate. You want look at what you're starting with. Now think about this. I have log base 5. What's the opposite of log again? Exponential. So I know at some point I'm going to write a big 5 on both sides. But before I can do that, I have to get that log 5 by itself. So what do? I'm going to divide by 2. So I have log 5, 3x equals 2. Agreed?
Yes.
Okay. Now, is my log all by itself? Yes, there's nothing being added, subtracted, multiplied, or divided. So how do I get that log little 5 to go away? I'm going to use a big base 5. So when I do that, everything goes up in the exponent. If you guys just want to write a big 5, like down to the side of it, that's fine. What you do to one side, you do where? So I have a big 5, and what goes in the exponent? The 2. Good. So my 5 log 5 does what? Cancels. So I have 3x equals, what is 5 squared? 25. What's my last step? Divide by 3. At this point, guys, you could leave your answer any way you want to. You could leave it as 25 over 3 if you want. If you're doing everything into decimals, you want to divide 25 divided by 3. What is it? 8.33333333. Okay. And then what do we can look at this and say, okay, if I put this right here, is it going to become negative? No. So we're good. Just always need to check and see if it's going to become negative. Now, what does this say right here, number 9? Checking for extraneous solutions. So what do you think might happen here? You might have an extraneous solution. All right, so here, I'm going to rewrite the problem down here so you can see a little better. It's the natural log of x minus 2 plus the natural log of 2x minus 3 equals 2 times the natural log of x. All right, there's a lot going on in this problem, but nothing we can't handle. It's just going to put a bunch of stuff together. Now, I have an equal sign, and I do see that there's ln's on both sides, right? Can I just cancel them out, though? No. The reason why I can't is because of this. If it was just one ln on one side and one ln on the other, I definitely could do that. But did we learn something 20 minutes ago that I could take this and smush it together? Yeah, right? How could I rewrite this? I could rewrite this as the natural log of what? X minus 2 times 2x minus 3. What did you guys just do there? You condensed it. If you can't, guys, if you have a problem that's pulled apart like that, you got a bunch of the same natural logs or same logs, smush them together. Can I do anything on the right-hand side? Did we learn anything that I could do on the right-hand side? If I'm going to smush together?
Oh, 2 would be the exponent.
2 becomes what? The exponent. Good, that 2 comes back here. So this becomes natural log of x squared. Do I now have one natural log on one side and one natural log on the other side? Yes. So what can I do with them? You can cross them off. And now this just becomes an algebra problem you guys have seen a million times. I'm going to FOIL. What's x times 2x? Okay, 2x squared. What's x times negative 3? Minus 3x. Negative 2 and 2. Minus 4x. And then negative 2 and negative 3. Plus 6 equals x squared, right? How do I solve this, guys? Combine like terms. And I'm going to move the x squared over, right? So I'm going to subtract the x squared and combine like terms. So I have x squared. This becomes minus 7x plus 6 equals 0. One more step. What do I do? Yep. What are the factors of positive 6? That gave me a positive 6 when I multiply, but a negative 7. Negative 6, negative 6, negative 1. So I got two answers here, guys. X equals 6 and x equals 1. Now, I'm proud of myself. I got 2 answers. I had x squared. I knew it was going to be 2 answers. What do I need to do? I got to check. I don't have to check the entire thing and make sure the left-hand side equals the right-hand side. I have to check to make sure of what? That nothing becomes negative. If I go back here, I had 6 and 1, right? If I put a 6 here, what's 6 minus 2? 4. That's fine. If I put a 6 here, what's 2 times 6? 12 minus 3, 9. Neither of those are negative numbers, right? Okay, so 6 is fine. 6 is good. We like 6. What happens when I plug in 1? Ooh, what's 1 minus 2? Negative 1. Guys, in your calculators right now, hit ln negative 1 and enter. What does your calculator tell you? Error. As soon as you get an error, it doesn't matter if it only makes one of them an error or one of them negative. As soon as you get a negative, it's like, oh no, that one doesn't work. So this would be extraneous. If you don't cross that off, write extraneous, say, Mrs. Meadows, this one doesn't work, something like that, then your answer is not completely correct. So you've got to make sure you let me know that something does not work.
What if you just don't put it in?
Like if you just circled 6 and left x minus 1 hanging out there, that's fine. Just do something to tell me, hey, this one works, this one doesn't. All right, I want to do one more problem. I have to make it up real quick. Hang on. All right, example number, what, 10? All right, last one, then we're done. We got through everything today. It's awesome. So we have plenty of time to practice now. Example 10. All right, write this down. It's a little different from what we started off with. What does this kind of look like? What does this kind of look like? Kind of looks like a factoring problem, right? Kind of looks like a quadratic. Guys, this is an exponential quadratic. The only time you will see a problem like, or when you see a problem like this, you answer it the exact same way every time. This is an exponential quadratic. This is the same thing as saying 2x squared minus 5x minus 7 equals 0. You guys are you're saying, what do you mean it's the 2x? Guys, if I multiplied e to the x times e to the x, what happens when you have the same bases and you're multiplying? You add the exponents, right? So this becomes e to the 2x. That's how this comes about. So when you have a quadratic, let's handle this the exact same way we would. Instead of x in the front of each of your parentheses, what do you think you put? An e to the x. This is just an exponential quadratic. Now we factor like we usually would. 2 times negative 7 gives me what? Negative 14. Are there factors of negative 14 that'll multiply to give me a negative 14 but add to give me negative 5? Minus 7 and plus 2. Perfect. All right, we're factoring like normal. Do I leave it like this? Am I done? No, my a term is not 1, right? So I have to divide both sides by 2. Everybody with me? So I have, does 7 divide by 2 pretty? No. So this becomes 2 e to the x minus 7. Minus 7 here. And this becomes e to the x plus 1. Because 2 divided by 2 is just 1. Now, with any other factoring problem, we would set each parenthesis equal to 0 and solve. So let's go ahead and do that. I have 2 e to the x minus 7 equals 0. Then I have e to the x plus 1 equals 0. So I'm going to come over here and solve this left-hand side. I'm going to add 7 to both sides. So I have 2 e to the x equals 7. Divide both sides by 2. And we have e to the x equals 7 over 2. All right, guys, now that my e to the x is by itself, I'm going to say, okay, I have to undo that. I have to get x, not e to the x. So what's the opposite of e to the x? So the ln. So if I have ln on one side, I'm going to take the ln, or natural log, on the other side. So on the left-hand side here, my e to the ln cancels. So I have e equals, and then you're going to do the natural log of 7 over 2 in your calculator. So natural log of 7 divided by 2, and you guys get 1.253. So we're going to take that, and we can plug it right back in to our original, both of our x values, and you can check your answer. So same thing here. I want to get my e to the x by itself, so I'm going to subtract 1 from both sides. So I get e to the x equals a negative 1. Now, guys, you want x, not e to the x. So I'm going to take the natural log When I take the natural log of e to the x, I'm going to take the natural log of the left-hand side. Some of you right now are like, wait a second, you can't take the log or natural log of a negative number, which is true. If you don't see that, no big deal. If you go to simplify this and in your calculator you hit natural log of -1, your calculator will give you an error message. So this is not a valid answer. So you actually only have one answer here, and that's how we solve our quadratic. This is an exponential quadratic. So you're going to move everything to one side, factor it like normal, and then we just treat it like we would a regular factoring problem.